Hyperbola. In the last section, we learned that planets have approximately elliptical orbits around the sun. When an object like a comet is moving quickly, it is able to escape the gravitational pull of the sun and follows a path with the shape of a hyperbola. Hyperbolas are curves that can help us find the location of a ship, describe the shape of cooling towers, or calibrate seismological equipment. The hyperbola is another type of conic section created by intersecting a plane with a double cone as shown below. The word hyperbola derives from a Greek word meaning excess. The English word hyperbole means exaggeration. We can think of a hyperbola as an excessive or exaggerated ellipse, one turned inside out. We defined an ellipse as a set of all points where the sum of the distances from that point to two fixed points is a constant. A hyperbola is a set of all points where the absolute value of the difference of the distances from the point to two fixed points is a constant. Hyperbola definition. A hyperbola is the set of all points q, x, y for which the absolute value of the difference of the distances to two fixed points, f1, x1, y1, and f2, x2, y2, called the foci, plural for focus, is a constant k. Absolute value of d, q, f1 minus d, q, f2 equals k. The transverse axis is the line passing through the foci. Vertices are the points on the hyperbola which intersect the transverse axis. The transverse axis length is the length of the line segment between the vertices. The center is the midpoint between the vertices or the midpoint between the foci. The other axis of symmetry through the center is the conjugate axis. The two disjoint pieces of the curve are called branches. A hyperbola has two asymptotes. Which axis is the transverse axis will depend on the orientation of the hyperbola. As a helpful tool for graphing hyperbolas, it is common to draw a central rectangle as a guide. This is a rectangle drawn around the center with sides parallel to the coordinate axes that pass through each vertex and covertex. The asymptotes will follow the diagonals of this rectangle. Hyperbola centered at the origin. From the definition above, we can find an equation of a hyperbola. We will find it for a hyperbola centered at the origin C0, 0, opening horizontally with foci at F1, C0, and F2, negative C0, where C is greater than 0. Suppose QXY is a point on the hyperbola. The distances from Q to F1 and Q to F2 are d, Q, F1 equals the square root of x minus c squared plus y minus 0 squared equals the square root of x minus c squared plus y squared. d, Q, F2 equals the square root of x minus negative c squared plus y minus 0 squared equals the square root of x plus c squared plus y squared. From the definition, the absolute value of the difference should be constant. Absolute value d qf1 minus d qf2 equals absolute value of the square root of x minus c squared plus y squared minus the square root of x plus c squared plus y squared equals k. Substituting in one of the vertices, a, 0, we can determine k in terms of a. Absolute value of square root of a minus c squared plus 0 squared minus square root of a plus c squared plus 0 squared equals k. Absolute value of the absolute value of a minus c minus the absolute value of a plus c equals k. Since c is greater than a, the absolute value of a minus c equals c minus a. Absolute value of c minus a plus c equals k. K equals the absolute value of negative 2a equals the absolute value of 2a. Using k equals 2a and removing the absolute values, move one radical. Square root of x minus c squared plus y squared minus square root of x plus c squared plus y squared equals plus or minus 2a. Square both sides. Square root of x minus c squared plus y squared equals a plus or minus 2a plus the square root of x plus c squared plus y squared. X minus c squared plus y squared equals 4a squared plus or minus 4a multiplied by x plus c squared plus y squared plus x plus c squared plus y squared. Expand. X squared minus 2xc plus c squared plus y squared equals 4a squared plus or minus 4a multiplied by the square root of x plus c squared plus y squared plus x squared plus 2xc plus c squared plus y squared. Combining like terms leaves negative 4xc equals 4a squared plus or minus 4a multiplied by the square root of x plus c squared plus y squared. Negative xc equals a squared plus or minus a multiplied by the square root of x plus c squared plus y squared plus or minus a multiplied by the square root of x plus c squared plus y squared equals negative a squared minus xc. A squared multiplied by x plus c squared plus y squared equals a to the fourth power plus 2a squared xc plus x squared c squared. A squared x squared plus 2a squared xc plus a squared c squared plus a squared y squared equals a to the fourth power plus 2a squared xc plus x squared c squared. A squared y squared plus a squared c squared minus a to the fourth power equals a squared c squared minus a squared x squared. A squared y squared plus a squared multiplied by c squared minus a squared equals c squared minus a squared multiplied by x squared. Let b squared equal c squared minus a squared since c is greater than a, b greater than 0. Substituting b squared for c squared minus a squared leaves a squared y squared plus a squared b squared equals b squared x squared. Divide both sides by a squared b squared. Y squared divided by b squared plus 1 equals x squared divided by a squared. Rewrite. X squared divided by a squared minus y squared divided by b squared equals 1. We can see from the graphs of the hyperbolas that the branches appear to approach asymptotes as x gets large in the negative or positive direction. The equations of the horizontal hyperbola asymptotes can be derived from its standard equation. X squared divided by a squared minus y squared divided by b squared equals 1. Solve for y. Y squared equals b squared multiplied by x squared divided by a squared minus 1. Rewrite 1 as x squared divided by a squared multiplied by a squared divided by x squared. Y squared equals b squared multiplied by x squared divided by a squared minus x squared divided by a squared multiplied by a squared divided by x squared. Factor out x squared divided by a squared. Y squared equals b squared multiplied by x squared divided by a squared multiplied by 1 minus a squared divided by x squared. Take the square root. Y equals plus or minus b divided by a x square root of 1 minus a squared minus x squared. As x approaches positive or negative infinity, the quantity a squared divided by x squared approaches 0 and square root of 1 minus a squared divided by x squared approaches 1. So the asymptotes are y equals plus or minus b divided by ax. Similarly, for vertical hyperbolas, the asymptotes are y equals plus or minus a divided by bx. Their standard form of an equation of a hyperbola centered at the origin c, 0, 0 depends on whether it opens horizontally or vertically. The following table gives a standard equation, vertices for foci, asymptotes, construction rectangle vertices, and graph for each.